Hello students, welcome to Become a Good Problem Solver event organized by the GYM Foundation. This video showcases the solution for senior problem published in the January 2026. The problem is a very interesting exploratory problem that gives children an idea of how you can identify patterns and come up with interesting conjectures. As always, if you want to solve a problem systematically, the GEM Foundation follows a very good approach shared by the mathematician George Polya about the four-step technique to solve the problems systematically. Understand, plan, execute, and reflect. So you can follow this upper technique to solve math problems systematically. As it's mentioned, understanding a problem is like half solved. So, in order to have a very good understanding, children can follow different steps, like, for example, underlining the key terms and then asking themselves a guiding questions on what do I know, what is asked in it, what are the important information, how can I connect concepts to find ideas to work on a problem. So these are the guiding questions which can help any student to work on a problem, and for that they can actually also utilize drawing or visualizing the problem in a way that they can find ideas they can apply, and also rephrasing in their own words. So by doing this and systematically recording whatever they have done, they will look for interesting patterns that will help them work on a problem and arrive at a solution. So let's see how Uber technique can be applied for this problem, which is an exploratory problem. So first, let's read it and then underline the important key terms. So in this problem, it's been mentioned perimeter of a rectangle is 20 centimeters, and different rectangles having perimeter 20 centimeters can be drawn. Yeah, which of these rectangles give maximum area? And take different even perimeter values like 22, 24, etc. Can you find a pattern of the rectangle dimensions that gives maximum area? So this is the question that is being asked, and let's see what are the guiding questions. So draw different rectangles having perimeter 20 units. So you might all know that the perimeter of a rectangle or perimeter of any shape is the distance that is covering the outer boundary, right? So in a rectangle, if you consider this is length and this is breadth, from if you start from here, then the perimeter of a rectangle would be, this is L, B, L and B. So L you add 2 times and then B 2 times. So you know that there are two lengths, so you can put 2 length and 2 breadth, which you can say it as 2 times. If you apply the distributive property inverse, you get this as a perimeter, right? So here in the case of a rectangle, they are first asking that there can be different perimeters. So how do we find that is the first important guiding question. So let's say for 20 centimeter, if the perimeter is 20, then 2 times L plus B is 20. So what is L plus B then? 20 divided by 2, and that is 10. Okay. So what are the different ways I can get L plus B as 20? So that is what you may need to actually find, that what is L and B, which gives me a value 10. Maybe we can have 9 and 1. Yeah, 9 plus 1 is 10. And you can have the area for this value. So whenever you work on the problem, mathematical recording is very important on how you actually record your observations and the way you work. So in this case, the first one, L and B, if 9 and 1 are there, you get a perimeter 20. And what is the area? It will be 9 in terms of unit, it will be square unit. And then any other ones? Yeah, 8 and 2, that is also 10. And then the area would be, the area of a rectangle is length times breadth, right? So you just need to multiply and see how many unit squares are there. So here 9 times 1 is 9, and then 8 times 2 is 16. 7 times 3, Yeah. So 7 times 3 is 21 and 7 plus 3 is 10. And then 6 plus 4 is also 10. And you may get 6 fours are 24. And then 5 and 5. Yes, this is a rectangle, which is a special rectangle, and that's a square. Yeah. And then the area is 25 units, square units. So for the first question on which of those rectangles gives maximum area, can you figure that out? Yes, it is. The area is 25 for a rectangle, which is a special rectangle in this case, having dimensions 5 and 5, and that results in a square. So the perimeter is 20 and the area is 25, and that's the maximum area. So the question also encourages students to actually explore different even perimeter values, which means like 22, 24, etc., and asking us to find a pattern. So let's try doing the same kind of a table here, with length and breadth and then the area. So for example, when you have a perimeter as 22, right? So when you have a perimeter of 22, you can actually check that the length and breadth, which one would give that. So if the perimeter is 22, then 2 times L plus B is 22, and then so L plus B is 11. So you can put a same table wherein you get which values to add 11, right? So if I have another table, so this is for perimeter 20 and again for perimeter 22. If we have, then maybe you can get 10 and 1, 9 and 2, and then 8 and 3, 7 and 4, 6 and 5, and then 5 and 6 it repeats, right? So if you put the area, 10 times 1 is 10, 9 times 2 18, 24, 28, and 30. Okay, so now you know that for each you can actually use this as a secondary table and then put here the your conclusion on what you get as a dimension. So for example, if you have a perimeter of 20, then we figured out that the length and breadth of this, which resulted in a bigger area, is a square. And for 22, we just now found that it is 30 is the maximum area and 5 and 6, right? So you can, maybe it can be 5 and 6 or 6 and 5, and that is 30. And let's see for 24. So do you really need to actually work this out, or can you kind of guess in this case? Just do a pause and guess while we actually work on it. So here again, perimeter is 24. So 2 times L plus B is 24. And then L plus B is 12. Right? So what are the different ways to get 12? 11 and 1, 10 and 2, 9 and 3, 8 and 4, 7 and 5, 6 and 6. So obviously here you can easily say that it is quite evident that the 6 and 6 is the biggest one, right, with 35 and 36. So you can actually make the table here and then put 6 times 6 is 36, which will get a perimeter 24 and area 36. So now pause and kind of fill for different other perimeters. Okay, so if you follow the same steps, you can actually figure out that these are the values you might be getting for a specific perimeter and what are the length and breadth that gives a maximum area. Now, there are two important things while you work on such exploration problems. The first is working systematically, meaning you're not taking some random values but taking even perimeter, and also in even perimeter, you use some kind of consistent values so that you recognize some patterns. And another thing is the way that you actually build up this table. You're not kind of cluttering the table with these values, but then using the secondary table to get the value and then updating here. So this will actually help you recognize the patterns. Now, let's see what interesting pattern we have in this one. Can you actually see what are the, so the question actually ask you to find the rectangle dimensions, any pattern on that. So U5 5 5 65667777888. Now recognize this. Take a minute, pause here, and recognize any pattern that you can see. Okay, now coming back from your pause, I'm sure that most of you could have seen that these are all square numbers, right? 25, 36, 49, 64, all of them are square numbers. So, square is the maximum area for a given perimeter. And there can also be some numbers which cannot be a square number, but what is special about these dimensions? It's not a random dimension, but 6 times 5. And then if you go further, 6 times 7, 7 times 8. And maybe next after this would be 8 times 9. So these are consecutive numbers, right? 6 and 5, 7 and 6, 8, 7 and 8. These are consecutive numbers. So, what you can kind of infer from this is for any given perimeter, the area is maximized in two cases. One, it could be a square dimension, or it could be only a rectangle with a consecutive number dimension, meaning the length and breadth are kind of mostly coming up with a square, but then coming up back from just one. So like 3 and 2 and or 3 and 4 or 4 and 5. This is a very important observation because you may have some optimization problems where for a given perimeter what could be the maximum area, and you can find this using a very simple kind of observation on what dimensions you get. For example, if the number perimeter I'm having is 248, so what could be the area? So do you really dimensions and resulting in maximum area? Do you think you have this? You have to put these tables. Does this a smart way? Yes, it's a smart way in the start, but not after you build this table and made observations. So what you can do is basically the perimeter divided by 2, you get the L plus B, right? So 248 divided by 2 is 12 and then 4. So 124, you actually divide again by 2 and get the quotient because L and B are more or less should be same, right? So you divide either divide by 4 entirely or divide by 2 times. So you get 62. And therefore, this results in a square 62 by 62, and the area maximized would be 62 times 62. That would be the maximum area. But what happens if it is 250? You can still divide 250 by 2 and then 125 by 2, or you can directly do 250 by 4 and take the quotient. So in this case, the quotient would be 262, and then there would be a reminder of so it is a reminder of 2, right? If there is a quotient and the remainder, then you take a consecutive number because that's what we have been doing in other examples. So it should be 62 times 63 of a maximum area for 250 perimeter. So, just by working on these problems, you develop a recognizing pattern skill and also coming up with conjecture like these with maximum area with integer area. That's also an important thing to be mentioned. And also finding a way or like a formula or an approach to find that maximum area for a given perimeter. I hope you enjoyed going through the solution, and I would encourage you to think on what would happen for a odd perimeter. This is the time for you to think, apply a similar systematic working, and you will be amazed to see yourself equipping with a very good different skills. Thank you. Keep tuning on to this BGPS event and submit your solutions. It will be available on the Gym Foundation / BGPS, published on 15th of the month, and you have 15 days to submit a solution. Thank you.